Hi, fifth grade. We are going to do another instructional video for math. And this is definitely me a little while ago. I'm looking to see what kind of math we're going to do today. I love this woman. She is like the most memeable woman ever. And she's looking. What does she see? We are going to do triangles. Triangles. How can we classify triangles? Forky does not know. I do know. Let's take a look at this is 11.2, and that is on page 643 in your chapter 11 book. Whether you're looking at a real chapter 11 book or you're looking at a online version of the chapter 11 book like I am, either way, taking a look at 643. And our essential question here, let me get myself a markup tool. Yeah, we'll go with green. Our essential question: how do you classify triangles? How can you classify triangles? How can we name different types of triangles? And I love the example they have here. If you look closely at the Epcot Center's Spaceship Earth building in Orlando, Florida, you may see a pattern of triangles. If you don't see a pattern of triangles in here, I think you're going crazy. The triangle outlined in the pattern has, at the right, has three congruent sides and three acute angles. What type of triangle is outlined? So this is the one that they're talking about. It has three congruent sides. That means that all three sides are the same. And it has three acute angles. And spoiler alert, if it has three congruent sides, then it has to have three acute angles. Um, so we can classify triangles two different ways. We can classify by lengths. We can classify by measures of their angles. That's the two different ways we can do it. Um, so if we look and think of these as two separate ways to classify, I'm going to split them in two there. It says an equilateral triangle has how many congruent sides? Well, it has one, that's 3 inches, two, 3 inches, three, 3 inches. Obviously, it's a triangle. Obviously, it's going to have three sides, and each side in this case is 3 inches. So it has three congruent sides. So this guy up here, this one on Spaceship Earth, is an equilateral triangle. Now there's lots of triangles on here, but this equilateral triangle is just like this equilateral triangle, which is just like this equilateral triangle. They're all triangles that have three equal sides. And that's kind of easy to remember too, because we have here equal. Now, I know it has an I in it instead of an A, but it's still equal. It means the same. Second way to classify with side length, the second kind is an isosceles triangle. You will note that the isosceles triangle has two congruent sides, 3 inches, 3 inches, and then it has another side that's a different length. In this case, it's 2 inches. So it only has two congruent sides. That's an isosceles triangle. I like to think of that one as kind of just like a tall triangle, especially if you think of it in this orientation instead of this orientation. This guy is equilateral too. These appear to be the same size, and this one is a separate size. So isosceles and equilateral so far. A scalene triangle has how many congruent sides? Well, we got a 3, a 4, and a 5. 3, 4, 5. It has 0 congruent sides. It is a weird looking triangle. It's weird looking because it has three different sides. And what it says down here below is that the type of triangle outlined in the pattern, and we're talking about this pattern up here in Spaceship Earth, can be classified by the length of its sides as what kind of triangle? Well, remember, that was this one up here. It is actually an equilateral. I know that's not very neat. I got this like big fat stylus, but I have some skinny styluses coming. So you have to put up with my big fat stylus writing for now. Now, the other way of classifying triangles was with its measures, the measures of the angles. And this guy over here, we can see that it has a 30-degree angle. They're talking about this one. And this one is 60 degrees, talking about that angle. And then this one, it doesn't have any numbers, but this right here, that is a big clue as to what kind of angle that is. If it has that box drawn, they're showing you that it is a 90-degree angle. 90 degrees. So a right triangle has one 90-degree angle, or one right angle. One right angle, that means it's a right triangle. That's easy to remember. An acute triangle has three, let's see. This one's 30. This angle is 75. This angle is 74. These two are the same. And this one's 30. Well, they're all less than 90 degrees. And this is an acute triangle. So I dare say that they're talking about this has three acute angles. Three acute angles? It's an acute triangle. Makes sense to me. And then, what is this mess? Oh, get this out of here. What a mess. This guy here, this is an obtuse triangle. It has one, what kind of angle? Well, this one's, what's going on here? This one is 18 degrees. This one's 32. These are acute. But this one right here, obtuse. Remember, those are the angles that are bigger than 90 degrees. They're great big open mouths. So 130 degrees. An obtuse triangle has one obtuse angle. Oh, that's terrible writing. Probably not any worse than what I do on the smartboard, though. So this triangle can be classified. When we classify it by the measures of its angles, we have to go back up to these and see which kind it is. Well, they're all less than 90 degrees. So I would say this is an acute triangle. Again, we're talking about these guys up here. 1, 2, 3. Those guys are all acute triangles. So, in fact, if you think about it, we can name that triangle, these ones up here, way up here, it has two different names. It's an equilateral triangle, and it is an acute triangle. And we would say that it is an equilateral acute triangle. Pretty cool. Question down here, is an equilateral triangle also a regular polygon? Now, regular polygons have all the sides the same, like a square, like a pentagon. What's he drawn? Uh-oh, he drew a hexagon. I can't help it. It's got 1, 2, 3, 4, 5, 6. 6 sides. That's a hexagon. Hexagon. Square. And an equilateral triangle, is it a regular polygon? Well, it has 3 sides that are the same length. So I would say that yes, it is regular. Equilateral triangle is regular polygon. And it's also an acute triangle. It's got lots of different names. but it's still the same triangle. And we're done with that page. I'm going to the next page here. I think we're going to this page with the share and show and the on your own, because it has some really good situations we can look at. Got to get that markup pen. Yeah, we're going to go with red this time. New page, new color. Share and show, classify each triangle, write isosceles, scalene, or equilateral. So there they're talking about the lengths of the sides, but we're also going to classify it by the angles too, obtuse, acute, or right. All right. Let's look at this one. Number one example. I got a 12-foot side, a 14-foot side, and an 11-foot side. So when we're thinking about the classification of it with length, I would dare say it's scalene because they're all three different lengths. So this guy, it's a scalene triangle. I think most would agree with that for sure. And is it acute, obtuse, or right? 51, 75, 54. There's no right angle. There's no obtuse angle. This guy is 100% acute triangle. Uh-oh. There we go. It's a scalene acute triangle. Pretty cool. How about this situation here? All right, so we have to classify it as isosceles, scalene, or equilateral. You know what? This looks just like that Epcot ball. And you know what? These little lines here, I've been drawing them, and they're drawing them too. When each side has one line through it, they're telling you that each side is the same. If they all have one line, they're all the same. So this is an equilateral. And when we think about the type of triangle it is in relation to its angles, it's not a right, it's not obtuse. We got another acute triangle here. Yeah. This one here, gosh, I think it's one of those tall triangles, because if we put it the other way, it's going to look like that. This guy is isosceles. Notice these two lines here? They're saying these two sides are the same. But this one over here doesn't have the same mark. Plus, it doesn't even look like the same length. So we got one side of one length and the other two sides are the same length. This is definitely a isosceles triangle. Oh my. Isosceles is tricky. I-S-O-S. And then C-E-L-E-S. Wow, you can't even read that. Isosceles. And when we think about the angles, is it acute, obtuse, or right? And once again, we got less than 90 degrees, less than 90, less than... This guy is an acute triangle. Certainly not obtuse, and I don't see any right angles there. So look at that. Each one of these triangles has two different names. Scalene acute, equilateral acute, isosceles acute. Aren't they cute little triangles? Yes, they are, because they all have less than 90 degrees. Look at this. On your own, a triangle has sides with the lengths and angle measures given. Classify each triangle. Write isosceles, scalene, or equilateral. Then write acute, obtuse, or right. So we're going to classify them by side length and by angles. They haven't even drawn it. How on earth would we figure that out? We don't. They haven't drawn it. But look here. We don't even have to see it. I don't think. I don't think we have to see it. We got 3.5 and 3.5. Those are the same. Then this one's longer. So we got two of the same. One is different. This guy, if you classify it by sides, is going to be an isosceles. Oh no, I've got to spell it. ISOSCELES. Isosceles. It looks terrible. And then angles, we have to look at that. We got two really small angles, 27 degrees. These guys are acute angles, but this one's obtuse. And if it's got one obtuse angle, then it is an obtuse triangle. All right. Here we got sides of 2 inches, 5 inches, and 3.8 inches. Those are all different. So when we classify it by sides, we're going to say that this is a scalene triangle. And when we classify it by angles, here's a small angle. It's acute. This is acute. This one, though, is obtuse. So we're going to have to call it an obtuse triangle. It's scalene obtuse. And this is isosceles obtuse. What fun. Circle the figure that does not belong. Well, they're all triangles, so they all fit that category. I'm okay with them being triangles. But this guy's right. He's got a right angle. This is what do they call that? An equilateral triangle. Oh, this one's right, though. And if these two are right triangles, then this guy does not belong. By Sia. These two are similar because they're right triangles. Go deeper. Draw 2 equilateral triangles that are congruent and share a side. Ooh. 2 equilateral, so two triangles that have 3 sides that are the same length and share a side. What polygon is formed? Well, I'm going to try that. I'm going to try it. I'll give it a try. See, we'll do. We'll pretend as here. I can show you they have equal sides because I'm going to draw these lines on them, so you're sure. And if they shares a side, I'm going to make it share like. Look at that, congruent. They all have the same sides. What did we make? Yes, you are correct. It is a rhombus. It's a rhombus because it's one of those pushed over squares. It's like a square, and then somebody pushed it over right there, and it got pushed over and it looks like that. That's how I remember a rhombus. That's supposed to be a tricky question, and I guess it kind of is, but if they share a side, then they're going to form a new. Actually, it forms a quadrilateral, doesn't it? Forms a quadrilateral and a rhombus. All right. Done. Next page. Look at this. I get to keep the pages. All the work's still on it. And you know what? I can share this with you if you need them. Don't forget, you can go to Math on the Spot. Let me get my tool. Uh-oh. Wait, no. Yeah, that's it. Markup. Don't forget, you can go to Math on the Spot. You can scan this QR code with any device, and it's going to take you to the Math on the Spot video with Dr. Berger or Rena or what's her name? It's Dr. Berger, Rena, and Martha. So that's another little, that's more reinforcement for you if you need it. Practice and homework. Oh no. Well, we're not really assigning these, but I think it's a good idea after watching this video to maybe try some. Um, I can't stop myself. I'm going to have to try a couple. There's no stopping me. I'm going to get my markup tool. I'm going to get myself a brand new color. I'm thinking, oh, let's be crazy and do black. Oh, so exciting, Mr. Pelgood. I know. We're going to do black. What's this guy? So we have to classify it two ways: isosceles, scalene, or equilateral, and also obtuse, acute, or right. Now they're showing these two sides the same length, but this one is not. This one down here is a different length. So it's going to be an isosceles. ISOSCELES. So I know how to spell it. I just can't write it. That's fantastic. But now we need to classify it by the angles too. Acute. 118. That's more than 90 degrees. That guy's a what? Correct, Max. You're correct. It is obtuse. Max always knows the answers. Let's look at this one. Let's see. It's got two acute angles. Wait, it's got three acute angles. It's acute. But how can we classify it by lengths of sides? 50 and 50. These two are the same. This one's 15. It is not. So I would say that this is isosceles. I cannot wait to get a skinny stylus. This stylus is horrible. But it's the only one I have at home, so I gotta deal with it. And it's better than my finger. So we did by angles, but we also have to do by sides. Oh no, we did by sides. We have to do by angles. This guy has all three acute, so it's an acute isosceles triangle. There's some more down here where you can't even see it. You can't see the triangle, but you know everything about it. You know everything about it. How about, since we're here, we do this one? I'm going to let you think, what kind of triangle is this based on its angles? Ooh. I'm going to give you a hint. Look at this guy right there. What kind of angle is that? Correct, Harley Krebs. It is a right angle. That makes this that's right, a right triangle. All right. We also have here, we did it by angles. We have to do it by length of sides too. This is 25, 24. Oh, they're close, so close, but they're different in 7 inches. How about Audrey Gardner? Audrey Gardner, what do you think it is? Agree. It is definitely scalene. It's scalene, right? Pretty good, guys. Pretty good. You might want to try some more of these. And over here, as you know, let me hit done, done, done. Over here, you have the lesson check. These ones would be good ones to try. And also the spiral review. You'll see some more polygon stuff down at the bottom here. Here and here. But here looks to be kilometers and centimeters. Here. How many tons are equal to 40,000 pounds? Oh, a division problem. Oh, God, I gave it away. It's a division problem. Hey, hopefully this is helpful to you in thinking about how can we classify triangles. And I dare say it's a little bit, it's a little bit more exciting than a Mr. Perry video. Don't tell him I said that. He probably won't watch this whole thing. Don't tell Perry I said that. He's probably going to, nah, he won't watch the whole thing. He won't watch it till the end. He'll never know. He'll never know that I think my video rocks. All right. Enjoy doing your reteach page on Seesaw. And don't forget, there's going to be a follow-up activity too. You can do it as well. Have a wonderful day.